Hello students, I am Ekta. We have learnt about polynomials, types of polynomials and also monomials, binomials, trinomials and degree of polynomials in our previous session. In this session, we will learn about zero of a polynomial. Before going to the topic, let us discuss few points. Students, do you know what is the value of polynomial at a point? Do you know how to find the value of a polynomial? Learning outcomes. After completion of this session, you will be able to understand the value of polynomial at a point. Find the value of polynomial at a point. Find the zero of a polynomial. Remainder theorem. Factor theorem. Keywords. Polynomials. Zero polynomial. Constant polynomial. Linear polynomial. Remainder theorem. Factor theorem. Let us recall some points from our previous session. Monomial. A polynomial with one term is called monomial. Examples 3x, 4y, x square and so on. Binomial. A polynomial with two terms is called binomial. Examples x plus 4, 3y cube plus 4x square plus 1 and so on. Trinomial. A polynomial with three terms is called trinomial. Examples x square plus x plus 4, 2x cube plus 3x square plus 1, x square plus x plus 5 and so on. Let us learn about the zeros of a polynomial and value of a polynomial. The value of a polynomial p of x is p of a when x is equal to a. P of a is called the value of polynomial at x is equal to a. Zero of a polynomial. A real number m is said to be zero of a polynomial p of x if p of m is equal to 0. This is also called as the value of p of x at x is equal to m, and if m is 0 then p of m is equal to 0. Let us see some examples to find the value of polynomial at certain point and zero of polynomial. Example 1. If p of x is equal to minus x square minus 2x plus 6, if we put x is equal to 1 in p of x, we get p of 1 is equal to minus 1 square minus 2 of 1 plus 6 is equal to 3. Three is the value of p of x at x is equal to 1. Similarly, The value of p of x when x is equal to 2 is p of 2 is equal to minus 2 square minus 2 of 2 plus 6 is equal to minus 2. So, minus 2 is the value of p of x at x is equal to 2. Example 2. Find the value of each of the polynomial at the indicated value of variables. P of x is equal to minus 5x cube minus 2x plus 5 at x is equal to 2. Solution. Consider p of x is equal to minus 5x cube minus 2x plus 5 at x is equal to 2. The value of p of x at x is equal to 2 is p of 2 is equal to minus 5 into 2 cube minus 2 into 2 plus 5 is equal to minus 40 minus 4 plus 5 is equal to minus 39. P of x is equal to x square minus 9 at x is equal to 4. Consider p of x is equal to x square minus 9 at x is equal to 4. The value of p of x at x is equal to 4 is p of 4 is equal to 4 square minus 9 is equal to 16 minus 9 is equal to 7. P of x is equal to minus 2x plus 12 at x is equal to 3. Consider p of x is equal to minus 2x plus 12 at x is equal to 3. The value of p of x at x is equal to 3 is p of 3 is equal to minus 2 into 3 plus 12 is equal to minus 6 plus 12 is equal to 6. Now, consider the polynomial p of x is equal to x cube minus 1. What is p of 1? Note that p of 1 is equal to 1 cube minus 1 is equal to 0. As p of 1 is equal to 0, we say that 1 is a 0 of the polynomial p of x. Similarly, you can check that 5 is a 0 of r of x, where r of x is equal to x minus 5. In general, we say that a 0 of a polynomial p of x is a number of c such that p of c is equal to 0. Also observe that the 0 of the polynomial x minus 5 is obtained by equating it to 0. That is, x minus 5 is equal to 0, which gives x is equal to 5. And r of x is equal to 0 is a polynomial equation, and 5 is the root of the polynomial equation r of x is equal to 0. So, 5 is the 0 of the polynomial x minus 5 or a root of the polynomial equation x minus 5 is equal to 0. Now, consider the constant polynomial 8. Can you tell what its 0 is? It has no 0 because replacing x by any number in 8x power 0 still gives us 8. A non-zero constant polynomial has no 0. Okay, Students, now one important query will be raised, that is, what are the zeros of the zero polynomial? Every real number is a zero of the zero polynomial. Let us see some more examples on zeros of the polynomial. Example, check whether -4 and 4 are zeros of the polynomial x minus 4. Solution, let p of x is equal to x minus 4. Now, p of 4 is equal to 4 minus 4 is equal to 0. P of minus 4 is equal to -4 minus 4 is equal to -8. Therefore, we can say that 4 is the only zero of the polynomial x minus 4. Example, find the zero of the polynomial p of x is equal to 4x plus 5. Solution, given p of x is equal to 4x plus 5. Finding zero of the polynomial is same as finding the equation for p of x is equal to 0. So, 4x plus 5 is equal to 0. 4x is equal to -5. X is equal to -5 by 4. So, -5 by 4 is the zero of the polynomial. P of x is equal to 4x plus 5. Now, let us define the general form for the zero of the polynomial in the form p of x is equal to ax plus b. So, ax plus b is equal to 0. Ax is equal to minus b. X is equal to minus b by a. So, minus b by a is the only zero of the polynomial p of x is equal to ax plus b. That is a linear polynomial has one and only one zero. Let us see one example. Verify whether 5 and 0 are zeros of the polynomial x square minus 5x. Solution, let p of x is equal to x square minus 5x. Then p of 0 is equal to 0 square minus 5 of 0 is equal to 0. And p of 5 is equal to 5 square minus 5 into 5 is equal to 25 minus 25 is equal to 0. Hence, 5 and 0 both are zeros of the polynomial x square minus 5x. Let us check the statement of remainder theorem and factor theorem. Remainder theorem. Remainder theorem states that for any polynomial whose degree is greater than or equal to 1, if it is divided by a linear polynomial q of x such that q of x is equal to x minus a, the remainder of this division is always equal to q of a. This theorem is very helpful in finding the remainder of the polynomial without actually performing the division. Factor theorem. The factor theorem states that if f of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is a factor of f of x if f of a is equal to 0. In other words, we can say that x minus a is a factor of f of x if f of a is equal to 0. These theorems will be clearly explained in our next session, and also we will learn the geometrical relationship of polynomials where we can show the zeros of the polynomials using graphs in later classes. Points to remember. A zero of a polynomial need not be 0. 0 may be a zero of a polynomial. Every linear polynomial has one and only one zero. A polynomial can have more than one zero. Thanks for watching. Like, share and subscribe.